Okay, some of the strategies that you need to use for handling the AP multiple choice section with no calculators is to be able to simplify numbers. So if you'll see in the first example, I took 0.050 moles and wrote it in scientific notation, because I can do 5 times 6 pretty easily, and I'm choosing 6 because I'm converting using Avogadro's number. So in this problem set, you're going to see I have 5 times 10 to the negative second moles times Avogadro's number times 8, because there are 8 hydrogen atoms in this formula. So if I do 5 times 6, that gives me 30 times 8 is 240, and then if I add my exponents of minus 2 and 23, I get 10 to the 21st. I just have to reformat it to get 10 to the 23rd. And if you see, the numbers are all pretty much close to the same exponent, so you might even be able to say, oh, it's 2.4, and move on without taking time to actually do the conversion. For the next problem, it's a little harder numbers. You'll see that I took 17.8 grams of magnesium hydroxide. Over here, I calculated its molar mass, which is about 60. So if I take 20 divided by 60, I get 1/3 or 0.30. So even though I've rounded off, I can figure out that D is the correct answer without a calculator. Okay, for letter C, first thing you have to do is balance the equation. And once you balance the equation, it's not too bad. 2.43 times 2, it's all even multiples, so you can get even 2.4 times 2 gives you 4.8, and not even worry about going out to the extra digit. None of them that are that close that you would have to do that. For number 4, same thing. I'm balancing the equation, starting with my 200 grams of ammonia. Okay, molar mass of ammonia is 17.04. It's a 5 to 4 mole ratio of ammonia to oxygen, and you'll see I'm a little sloppier with my labels. Again, not taking the time maybe to fill every piece out, and then 32 grams per mole for oxygen. You'll see I took the 32 divided by the 17 and figured out that that's approximately 2. I took the 4 and divided that into 200 and got 50. So instead of having all of these numbers, I have 50 times 5 times 2, which I can come up with 500. Either way, 50 times 5 being 250 times 2, or doing 5 times 2, which is 10 times 50 is 500. So knowing that it's in the magnitude of 500, I can very easily pick out the correct answer there. For number 5, looking through the moles of ions, so I'm starting with 1.6 moles, and for the whole compound there are 4 moles of ions. There are 3 moles from the NH4, 3 ions of NH4 plus 1 mole of PO4, which gives me a total of 4. So 16 times 4 is 64, so 1.6 times 4 is 6.4 moles. Since balancing in redox seems to be a difficult concept, you'll see that I have that on here. I went through the balancing concepts for each of the half reactions and then added those together. So this one, there's really no shortcut to it, but understanding that they're going to have all the pitfalls in here. So selecting your correct coefficient when you're done the equation, but just another example of that for you to look at. So wanted to include that. On the back is just some practice operations with scientific notation. I think that's an important concept for you to be able to do. And again, you might need to review your rules for that, but there is a math handbook in the back of your AP book if you need to review those rules at all. And again, you can see that I have set this problem up in the way we normally do it, but what might be easier is looking at these numbers. I have 100, which is 1 times 10 to the second, 1,000, which is 1 times 10 to the third. So I end up with 15 divided by 1 times 10 to the fourth, or 1 times 10 to the negative fifth, excuse me. And then when I adjust that for 15, making 1.5 times 10 to the negative fourth kilometers. For number 2, again, just factor label problem solving, rounding off the number. The answer is 320, but just rough estimates. You can factor the 3 out of the 12, so you can get 4 times 2 is 8, times 4 is 32. I can drop these 2 zeros here, cancel out these 2 zeros with 1 0, and get the 320 that way, or rough estimate, 300 candy bars to 1 sig fig. So again, the other ones you'll see I'm doing the scientific notation with the exponents so that we can get through the problem faster to get the final answer. So just more practice with that of kind of estimating, converting numbers to scientific notation, and getting through that way. Okay, so this one I did 3 times 2 to get 6 times 5 is my 30, and then 10 to the 4th to get my answer, and then converting to proper scientific notation.